Hello, my name is Steve McQuarrie, and I am a technical marketing engineer with Cisco's Server Switching and Virtualization product group. This video is part of a series that is intended to show some of the unique advantages made possible by Cisco's server offering called the Unified Computing System, or UCS for short. This video will show the viewer the advantages of the Cisco Virtual Interface Card, or Cisco VIC, in a standalone Cisco UCS C-Series server in a classical Ethernet environment. Specifically, we want to look at how the Cisco VIC allows users to eliminate the need for the OS to understand trunking from the switch. This will enable users to streamline network connectivity and provide maximum flexibility. We will also demonstrate how the VIC allows users to add additional networking connectivity without the need to physically access the server or add additional cabling. Let's start by accessing the standalone Cisco Integrated Management Controller, or SIMC. SIMC is an out-of-band management controller that allows us to configure the server, including the Cisco VIC. If we go under Inventory, we'll see the Cisco VIC adapters. In previous versions of SIMC, you may have found it under Network Adapters. But if we take a look at the Cisco VIC, we see I have one installed in this system, and we see that there are two uplinks, uplink ID 0 and 1, both in classical Ethernet mode, operating at 10 gig. By default, there are two VNICs. The VNICs are the interfaces presented to the operating systems. We see each has a MAC address, and if we take a look at the properties, we see things like the MTU, select the uplink, the VLAN mode, which is currently in trunking. So if we take a look at how the switch is configured here, we see that port 0 is configured as a trunk port, as is port 1. So at this point, we are trunking from the switch all the way down to the actual OS. Since Windows 2008 doesn't natively understand trunking, we would have to add additional components to the system to be able to deal with that. But we're going to show you how we don't have to do that with the Cisco VIC. Here we're taking a look in the network properties, and we see that our VICs are both connected. We'll do a shutdown to verify that we have the right VIC here, the right switch and server. So we see that one became unplugged. Now, typically the type of configuration we're showing here, we would do prior to ever installing the operating system, but the purpose here is to show you the before and after of the server not understanding the trunking and then being able to understand what's going on. So if we take a look at the IP config of the server, we're going to see the interfaces, and if we go all the way up here to the top, we're going to see our two VIC interfaces. And we'll see the MAC addresses of those VICs match the ones we saw in the SIMC. And we'll also see that currently the IP addresses are self-assigned IP addresses. So we're connected to the network, the interface is up, yet we're not able to get a DHCP address. This is because the VNIC itself is currently operating in a trunking mode, which means that from the VNIC we're sending tagged frames down to the operating system. So to change this, we want to go into the properties and we want to change the VLAN mode to access. Then we're going to assign it to a VLAN. That means that the uplink will still understand the tagging, but the actual NIC to the operating system will untag the frames and it will manage the tagging up and down between the NIC and the switch. So we're going to put one of these ports in VLAN 10, the other one in VLAN 20. Now we're going to save these changes, and unfortunately to get these changes to activate, we're going to have to go reset the adapter on the system. Again, normally we would do this prior to ever installing the operating system, or at some point where the server was up, so we did not have to reset the adapter, because resetting the adapter, as we see here, will actually create or cause a reboot on the system. So once the system's back up, we're going to log in here, and then we're going to navigate back to our PowerShell, and we're going to take a look at the interfaces again. So now when we look at our IP config, we should see that instead of getting self-assigned IP addresses, we have IP addresses assigned to our two VICs, because now they came up, they're sending untagged frames, and the VIC is handling that up to the switch. So from an OS perspective, the virtual interface is not having to deal with tagging. So we see one of these is in subnet 120, one is in subnet 110, which is consistent with our two VLANs that we've assigned. So here we'll test pinging to each subnet to make sure we have total connectivity there in those two VLANs. Now, another advantage here is that we can go ahead and add additional VNICs to this particular server. So these will show up as PCIe devices to the operating system. So I'm going to create an Ethernet 3 here, and I'm going to add it to a separate VLAN. So this may be a DMZ or some other type of secure network or some different network that I need to connect this server to. So I'm going to add that as VLAN 30 as an access port. And then I'm also going to create another one here, but I'm going to make this one go up uplink port 1, which may be to a completely separate network. And this is going to be VLAN 40 in this case, and this will also be an access port. Now, essentially, I've just added 2 more network connections on this server without actually touching the server or having to cable anything up. It may turn out that I also want to change the MTU on these particular interfaces. So without going into the operating system and making changes to the adapter properties, I can go in and change the MTU of the interface, and we'll see that that will show up in the operating system as well once we get everything reset for this server. And I may decide that I want to clone Ethernet 0 up here, which is connected to VLAN 10. All of the same settings that I have for Ethernet 0, I'm going to create an Ethernet 5, but on this one I'm going to make it connect up through uplink port 1. And the idea is that I'm going to take these 2 ports in the same VLAN and I might bond them together, so some type of bonding mechanism. Now if we go back and look in the operating system, we see that these VNICs are not in this operating system yet, and that's because we need to reset the adapter and basically bounce the operating system. Once we do that, reboot, we see now that we have all of the additional VICs that we've added to the system, and we can go in here and take a look at the IP config, and we'll see that they did come up with the appropriate VLANs for the individual adapters as we expected. So 120, 130, 140 for those additional ones, and then the one we created that was also in VLAN 10 is also in VLAN 110. Now we also want to take a look at the MTU, and we see that the MTU for the 2 adapters that we made 9000 are also configured there, and again we didn't do anything in the operating system. To recap, network connectivities for Windows and Linux bare metal servers can be a challenge in many environments, and the Cisco VIC helps by providing the server admin the tools necessary to provide connectivity to the network with minimal configuration within the OS or on the network ports for the upstream switch. This ends this UCS Advantage video, where we show how the unique capabilities in the Cisco UCS can lead to simplified deployment models with much faster turnaround to meet the increasing demands of the business. Please go to www.cisco.com/go/UCS for printed collateral, including a brochure that highlights the information shown on this video. Thank you.